0 seconds. So what is it? dt by dv? This should be equal to tan 45. This should be equal to 1. At t equal to 0, velocity is 0. At t equal to 2, what is the velocity? So this will become 2 minus 0, v minus 0. So v equal to 2 meter per second. This I'll call v2. Speed of particle at 2 seconds. We don't know this, we'll call this one. And the displacement of body in first 4 seconds is asking us to get the displacement. In fact, it's a, what type of motion it is? Uniform excited motion. Or okay, we'll do one thing. We'll get expression for, I ended up V2, no? Okay, no, one more step, I'll go for it. T is equal to V, so this will become ds by dt. So further, this will become T dt equal to ds. 0 to t, 0 to s. T square by 2. S equal to t square by 2. Okay, for t equal to what time? 2 seconds is asking how much of displacement. Shall we go for 2 meter? Next, after this, it's a uniform excited motion. After this, the body will have uniform velocity motion. Here, uniform excited motion, uniform velocity motion. With what speed it will move? 2 meter per second. It move with a constant speed. So the next part of the problem will be for t less than 4 seconds. So the total distance covered will be you may encounter, what is the type of graph it is? Time versus velocity curve also will be there. Just be alert, that's all, nothing big. Just take the next one. Yeah, some very generalized questions. Match the column 1 with column 2. Here, okay, these are the first, or match row 1 with row 2. Anything you can write it here. No, we have the first one. This somebody. Row 1. Row 2. This is the row 1. This is a row 2. Okay, fine. Okay, now we have to match it here. What can be matching, like how we can do it? Okay, this is what Vx graph. Vx graph is a straight line. Then it's asking what can be acceleration. Is it a uniform or non-uniform or proportional to t or proportional to x? Screen is very small. I can't accommodate in the vertical one. So therefore I'm calling this a row 1, row 2. So here we'll have a this is row 1, this is a row 2. Okay, now the acceleration versus now Vx graph. How you define acceleration? Acceleration is in fact defined as v dv by dx. This is a slope. There's no problem with the slope. And the slope is constant. Look at that, tan theta is constant, but V is increasing, no? Here. I'm discussing for the graph A. We are discussing for the graph A. So therefore, this is increasing. This constant. So what do you expect this? This must increase. If this increases, so shall we pick up this? So therefore, what are the options? A, I'll write it as Q. Let's see what are other things now. Is it how it is proportional to with the time is asking. So therefore this. So shall we go for one more? Any option? Acceleration of particle directly proportional to t. No, not possible. It is not directly proportional to time here. What about, will it be proportional to distance? Acceleration, will it be proportional to distance? Directly proportional to distance. Yes, in fact, correct, no? Because dv by dx is a constant and the v is proportional to x. I'll write it equal to so therefore A is proportional to. So everything is discussion for the option A. So what finally we can conclude here for option A, it should be Q and yes. Yeah, you can see all the content at one place. Okay, now similarly, V square versus X graph. And there is a constant slope. V square equal to tan theta into X. Why can't be this A? And in fact, it's a uniform accelerated motion only. Similarly, so I'll just okay, you see that one. Acceleration is constant. Anything it will be. So V square is proportional to A. So no, the A is constant here. How A can be constant? Because the slope is, yeah, I'll put it here, constant. Because V square by X is a slope here, no? And what is V square by X? Should be equal to acceleration. So therefore the B, what happened, will be P. Acceleration of particle is uniform. Okay, let's come for this one. VT graph. I think everyone knows this. Here, acceleration slope of this should be equal to in VT graph. What is the slope? Will be acceleration, and the slope is constant. So therefore, it must be P. Come for this one. We have V velocity versus time square, T square. So let's get into the mathematics. This is for graph B. V by T square equal to tan theta. Equal to tan theta. So this I'll differentiate. So what is finally proportional to t? So acceleration is proportional to, so acceleration will be non-uniform. Okay, I'll pick up Q. What about acceleration? Anything proportional to x? Can we say anything about that? Acceleration, can it be proportional to x, that one? How to determine that? When it varies with the time, acceleration proportional to t means, so we'll write it here. I have here. Acceleration, how it will be proportional to x. We got it proportional to t, no? R, sorry, it should be R. I'll minimize it. Let's say I'm unable to see it properly. Okay, what do I got it like? Acceleration is proportional to t is what I ended up. The graph t. Okay, next again, we have to check it like it is non-uniform. It in fact is non-uniform. So Q also will come. No question of P. What about S? I think it's not proportional to X, no? It is not proportional to X, sir. How do we can show that one? So again, you write it as this is like it's from T you have to bring the X here. So this is you write ds by dt. I don't have place to scribble. I'll show it here. A proportional to T. Then here